Okay, so this is problem 17 from chapter 16 of Giancoli 6th edition. So now what we have is a triangle, equilateral triangle, and they give us the side of this triangle. So let's make a drawing of it. It's equilateral. The distance, the size of this triangle is given to us. It's a certain value d given to us. And we have on each corner a different charge. So here we have a positive charge, Q1, I'll put here positive. Here we have a negative charge, Q2. And here we have another negative charge, Q3. Okay, and we want to find the force on each one of these different corners. Okay, so drawing the forces is not so hard, it's just repulsive or attractive, and we'll have to add those two vectors on each corner, now coming from the forces of the other two charges. So it's just an addition of vectors. But what are the things that we have to remember that will be useful while solving this problem? First, that the triangle is equilateral, so we know that all the sides here are just 60 degrees. All these angles here are just 60 degrees. Okay. With that, I also know if I make this horizontal line here, I also know that this angle is 60 degrees and this other angle is 60 degrees. So this is going to be very useful when it comes to decomposing the forces. All right. What is the other thing that is important? The sort of quadrants. Once you have to enter the angles for your net forces in web assign. So remember how you're going to get your angle. You're going to use the ratio between the components of the net force that you get. And how you're going to enter in web assign? Well, you have to check if the x and y components are positive or negative. So let's make an idea here of the quadrants. In this first quadrant here, this is where fx and fy are positive. So the angle that you get is the angle theta that you will obtain. It's going to be something between 0 and 90 degrees. In this second quadrant, what we have is fx will be negative and fy will be positive. In this case, you get to the angle theta and you're going to enter it as 180 degrees minus theta. That's how you enter in web assign for it to accept. In the third quadrant, we have fx negative, fy negative. And how you're going to enter it? 180 degrees plus the value of theta that you obtain using this expression here. And finally, in the fourth quadrant, fx is positive and fy is negative. So you have two ways. Either you're going to use 360 degrees minus theta, or you just enter minus theta and web assign will also accept. Okay, so let's then set that. Let's get some examples. So let's start. Let me make the triangle again. And let's start with the force on this Q1 here. The net force on Q1. Okay, so because of Q2, we have an attractive force here. Okay, so this is the force on 1 caused by 2. And because of Q3, we have another attractive force here. So this is the force on 1 by 3. All right? How are we going to get the net force? We'll have to decompose these two. As we said above, the angle here is 60 degrees. The angle here is 60 degrees. So we have that the x component of the force on 1 by 2 is going to be equal to k, the value of q1, just the magnitude, don't include the signs here, the value of q2, again just the magnitude, the distance, the d squared, and then we'll put cosine of 60 degrees. Okay, it's good to keep track of the direction of this force. I know that this red is going to the left, so I'm going to say that this has a minus sign here. So I keep track that this is to the left. Okay, in the y direction, what do we have? I'm going to put it here. F force on 1 caused by 2 in the y direction is going to be q1, q2, the distance is squared, so this is just the magnitude of the force, and then we have to take into account also the angle, so sine of 60 degrees. Again, to remind myself the direction of this force, I'm going to put a sign here to remind me that this is pointing down. Okay, same thing we do for the force on 1 caused by 3 in the x direction and in the y direction. Again, the angles are the same, and both okay, again the angles are the same, but let's be careful here. Here we have k, q1, q3, d squared, and cosine of 60 degrees, but this one is really pointing to the right, no? So this is really plus. The other one here is k, q1, q3 divided by d squared, and this one is also sine of 60 degrees, and this one is also pointing down as the force above. Okay, so now we add all of these forces. So we'll have the total component in the x direction and the total component in the y direction. In the x direction, we are going to get, if you do these calculations, apparently we get a negative value. Okay, so meaning to the left. Okay, check that your numbers really give you this negative value, and in the y direction, oops, I made a mistake here. This is also pointing down, so we should have said that this is minus, right? Also down, and this one was to the right. All right, so in the y direction, for sure, we are going to get something pointing down. All right, so now we'll use Pythagoras to get the net force, the magnitude of the net force. And we are going to get the angle using this ratio. What do we get here? The x and the y components are negative. So if both are negative, that means, let's come back up here, both are negative, we are in this quadrant here, we are in the third quadrant, and therefore we will use this idea to enter the angle. So all the way down here, either you're going to enter your angle in Weber sine by doing 180 degrees plus theta, or if you want, you can also write minus theta and it will accept. One more, let's pick just one more example, and let's now look at the triangle again, and we want to get the force on this Q2, okay, on this Q2 caused by Q1 and caused by Q3. All right, so let's draw the forces. The force on Q2 caused by Q1 is attractive, so it's along this line here. So this is the force on 2 by 1. The force caused by Q3 is repulsive, so it's going to be like this. So this is the force on 2 caused by 3. Again, we go get the components of these forces. So the force on 2 by 1 in the x direction is going to be k, q1, q2, that distance is squared, and then cosine of 60 degrees, because this angle here is 60 degrees. It is pointing to the right. If I want to keep a track of it, I'll put this sign here. In the y direction, we have k, q1, q2 divided by d squared, sine of 60 degrees, and to keep track that is pointing up, I'm going to put this plus here. In the other force, well, that other force is completely in the x direction, the force caused by 3. It's k, q2, q3, d squared, and that's it. And it's pointing to the left, so let me put a minus sign here to keep track of that. In the y direction, there is nothing, Okay, so in the y direction it's just 0. Again, to get the net, I'm going to add this force to get the x component. I'm going to add to get the y component. I see that in the y component it will be positive for sure. In the x component will depend on the 2 here, but apparently we get a negative value. Okay, so we'll use Pythagoras to get the magnitude of this net force, and we can also find the angle using the absolute values of the ratio of the absolute values of the forces. Now, if x is negative and y is positive, so if x is negative and y is positive, that means that we are in the second quadrant. So to enter the angle so that our Weber sign accepts, we are going to use 180 degrees minus theta, and that will be it.